speaker is João Periquito. He's currently finishing his PhD at Berlin Ultra High Field Facility, and he mainly works on the development of novel techniques for renal MRI. He's going to talk about the open source imaging initiative, and he will try to point out what's the current status of the OSI platform and what's going to happen in the near future.
Good afternoon, everyone. Thanks for the presentation and the invitation for me here. I'm doing my PhD in Germany, so I'm not really part of the Benelux. I'm here to present the open source initiative, which is a project started by my master thesis supervisor, Lucas Winter. And first, I would like to start with a small picture. What is the aim of this project? We try to advertise and implement open source practices for software and hardware in the medical technologies, in MRI. And before I go deep in the project, I just want to share some of my motivation and personal experience, why I joined this project. So, like many of you, I had a lot of obstacles, and I still have a lot of obstacles in my PhD. And there was one point that, so in my PhD, it's about renal MRI. We are trying to use MR diffusion to get some information about the fraction of tissue, tubuli, and blood with the ultimate goal of finding a biomarker for early diagnosis of chronic kidney disease. So, and during my PhD, I had a lot of obstacles. And while I was reading a paper in a completely different field, I found this really cool method that I would like to apply to my data. But, I mean, the implementation of the algorithm would take me dozens, thousands of hours. Probably convince my supervisor to spend the time on this would be even harder. And I was really lucky because someone was kind enough to build the algorithm, to implement the algorithm, to validate it, and to properly share it. So in the end, I could use it. And instead of thousands of hours, it just took me dozens of hours to adapt to my needs and use it to my data. And sometimes it's not just about saving time. It's about whether you do it or you don't do it. Because if you need to convince someone that you were working on something that might be good and you need to spend thousands of hours to check it, probably you won't do it. So I felt the need just to give back to how can I increase the visibility of the open source projects? How can make people as lucky as me to have a chance to find some of the projects, some of the open source projects that might help them in the early state or medium state of their PhD. Because usually what we have, that was pointed out, I think, in the last session, we have system vendors that sells this equipment as a black box. And black box can be the system itself or can be the application. And we have this medical procedure. And sometimes we don't know what the components, or we want to try new things with the systems, and we cannot do it because it's closed. And our idea is just to create, instead of having a black box, just create a transparent box. And this can be done with open source. So this is one of small examples that I know. But this is a medical device to help to calibrate MR system. What is really, sorry. What actually it is, it's just a plastic piece to hold a spherical phantom in the coil. And this is sold as a medical device by the vendor. Does anyone want to make a bet how much it costs? Okay, it's cheaper. It's only 800 euros. And it's, even if you see it, it's badly 3D printed. And this piece shouldn't cost 800 euros. But this is just an example of research. But in reality, is that this MRI is amazing. And we can do medical diagnosis is a really nice tool, but the coverage is not that well. I mean, there are many places in the world that don't have access to that system. So you can, so this map shows the number of MR systems per millions of inhabitants. You see a nice coverage for Europe, but if you go for Africa and South America, that not really happens. And I came from a small southwest country in Europe, Portugal, and as you can see here, Portugal has like dark green, it's okay, but if you zoom in inside of Portugal, you see a huge asymmetry of the country. Most of the people live close to the coast, where are the big cities. And this creates also an asymmetry in the healthcare coverage, because the people who live here, more in the interior of the country, don't have easy access to healthcare. And it's common to see on the news that people are struggling. So in this example was someone who needs to travel 100 kilometers for getting an ultrasound. So probably that means traveling 100 kilometers back to go home, and maybe in 1 week or 2 weeks, travel another 100 kilometers for the treatment. Because in the end, the state needs to make a choose, and needs to choose between cost and benefit. And it's not efficient to spend a lot of money where not so many people live. But if there is a chance to lower the costs, maybe we can increase a little bit the coverage of the healthcare. So, but before, let's look how are the prices of the equipments. So we have the initial purchase price, which usually it's a most visible price, the price that people know when acquire the equipment. But you also have another hidden prices that in the long term will play a role in the total price. I would just want to mention the regular service and maintenance and the repair of spare parts and the ongoing consumables. And our idea with the OSI, it's like to apply principles to try to reduce not just the initial price, but maybe in the long term, reduce the other prices close to zero, or at least diminish a lot the other costs. And let's go back to MRI. And by applying principles of innovation and open source, maybe we can tackle these four aspects where you have, I think it's like the main cost for fMRI. So we have the scanner, we have the maintenance, we have the staffing, and we have the power space. So by collaborating as a community to build the knowledge how to build an MRI, maybe we can think about creating more business opportunities. Maybe small companies can just appear in small cities and maybe are the ones who produce the magnets for the hospitals or small clinics. Maybe by applying innovation, we don't think about a universal system for all the purpose, but some dedicated system for specific questions. Maybe a hospital, a clinic, they don't want like the universal system, but they must just focus on the head or extremities of the body. Or we can also think about children's MRI. And for the maintenance, because all the documentation will be provided, it's not unreasonable to think like in-house maintenance. Someone or two people with all the documentation responsible for the maintenance of such equipment. Education and training will be easier as well because everything will be provided. Maybe you also can do in-house training, and you don't need someone to fly from another country to your country to do the teaching and the maintenance. And can also, by applying innovation, can also work on simpler and safer hardware softwares. Because some of the times, it happened to me in my PhD, that I think I'm doing something, but actually I'm doing something completely different. And that could harm, I work with animal MRI, and there was a point that there was a risk of harm the animal because I don't know what the scanner was doing. And once I create an experiment to check what is really happening, I found out that, oh, there was no warning, there was nothing. And you can also think about making customized products for the customer, like was mentioned in the last talk, because sometimes in remote areas, for example, you don't have the energy output that you require for such component. But maybe if we change this component to a simpler one or a less capable one, but still enough for what we want, we can just give something where regions we don't have anything. So this is reality, poor access to MRI. And the vision of open source imaging is try to transform the world. Yes. So we can start by doing simple things. So for example, learn how to share the code. When you implement an algorithm, when you do a project, if you share it, it means that someone else can use it. Someone else can benefit from your work. And then we don't start from the zero. We all having a ground truth, and we can build on top of it. Publish our software, hardware, and data as open source. Use more open source tools in science. If more people are using an open source tool, it means more people will try to contribute that tool is make it better. If it's the whole community using it, I mean, it's a huge potential. Imagine all of these people using one tool. And yeah, certify an open source MRI for clinical use, but first build an open source hardware MRI as a reference system. And then we can adapt from this reference system and build the necessary infrastructure, documentation, safety, and standards. So with open source initiative, we want to tackle these areas in order to make our vision come true. With education, by creating business opportunities, by creating a democratized market when small business can rise and then create this low-cost magnet. Building a community. I mean, using the potential of the research community is amazing. I mean, all of the people trying to tackle one single question is I don't know what can be done. And the other thing is that if we think about the transparent technology, we can improve the safety and the reliability of that tool. And building the knowledge to create an MRI, that's how we present in the further slides. But first, what is this open source imaging? If you go to the website, you see it's a platform that tries to give visibility to open source projects. We have more than 660 open source projects online with around 200 supporters. If you click, the projects are divided by hardware and software, and we have many subcategories for each part of the hardware and software. And if you click on the project, you can read the title, you can read a short description about the project, but you have access to all the documentation to reproduce it. You have also information about the cost of the materials if you want to buy it and build it from the beginning. And you also have the contact of the person who created. So in case you have any question, you can contact that person. You also have access to the publications, because if you want to reproduce this project, you want to be sure that what you are doing is as much as close to the first idea. So you have the publication to verify that your standards and your results can be the same. So usually we have some events, usually accumulated to during ISMRM. In 2018, we started the discussion about the construction of an open source low-field MR system. It was an informal meeting hosted in Paris by the EC Open. The EC Open are an open source group that tries to rethink the ultrasound system in order to make it cheaper. Usually, ultrasound, it's around 5,000, 10,000 euros, and they want to make it for less than 600 euros. In 2019, we were in Montreal. We, together with Nicolas Tikoff and Aga, we organized the hackathon for MRI professionals. We call it MRathon. And the idea was to promote reproducibility, collaboration, and standards through open source. Basically, what happened, we invite project leaders of well-established open source projects, and we also invite trainees. And the project leaders pitch the project to the trainees, and the trainees could choose, more or less like what happened here. The trainees could choose between these projects. Everyone was a winner because the project leaders could have someone dedicated and motivated to work on the projects, and sometimes you just have some loose ends that working 2 days on it, you can just finish. And the trainees were really happy because they could contribute to that project and could meet the person, the people behind the project. In this hackathon, we also were space for a spontaneous project. A colleague of mine, he was not happy, so he comes from the fMRI field, he was not happy how the information was organized. In his field, there was some contradiction, especially with anesthesia, because there was a lot of unpublished lab report and there was a lot of contradictory informations. And he wants to find a way to organize this information. He met someone who helped him to implement this idea. And in the end, they work in some kind of a filter that you select the species, you can select the application, the anesthesia, and what are the influence of the anesthesia in different parts. And then you have access to just a simple sentence of which unpublished lab report or the publication that, and you can check if there is a contradiction between or if most of the people agree. And we also launched the wiki from the community to the community. The idea is that we have some people writing about their field of expertise, and this content will be reviewed and added like a wiki for MRI and to share open source projects. There will be also a forum that you can just ask any question, and there is a moderator that tries to reply to that questions. And now I just want to explain a few words. How can we build this open source, low cost, accessible open source with open source hardware development? So, I mean, most of you work in MRI, so you could be here to present this slide. MRI, it's amazing. You have a multitude of contrasts. You have relaxation, susceptibility, diffusion. It's not about getting information, the structural information. It's about getting information, how the organs are functioning, the performance of the organs. And because it's non-invasive, it's safe. It's a safe technology. And it offers a high spatial and temporal resolution. But it's complex and expensive. And especially clinical MRI systems have a magnetic field of 1.0 Tesla or higher. They use superconducting magnets. And these superconducting magnets are cooled down with liquid helium, which make it very expensive. On another spectrum, you could have low-cost, low-field MRIs with a magnetic field of 0.2. Of course, they don't offer as much resolution and they're not that fast, but you can also have a good diagnostic accuracy. And sometimes you don't need to reach as fast as possible to our destiny. You can take a few more time and just make sure that you arrive. So it's with this low field MRI that I want to spend some time. The strategy is first to create a desktop MRI and always focus on modularity. So you have a single component that is responsible for one task. And if you want to change that component, you just need to change that component. But also means that if someone in the community wants to contribute, they just need to know about this component, and they don't need to know about every little detail of the MRI. They just can contribute to small parts. Once we have the desktop MRI, the idea is that to scale this model to a clinical system. And by scaling, I'm not saying that increasing the level of complexity. The design is kept. You just scale it. You make it bigger. And then you can think about dedicated applications, maybe just a magnet for the head or a magnet for extremities or for children. And once we have this, the idea is that to scale it one level again for the whole body universal workhorse. And for doing these magnets, it's a permanent magnet, so we don't need liquid helium. It's like magnets, small magnets that you put in a circular array, and then you put many of these circular arrays, and you create a homogeneous magnetic field, enough for creating an image. So Lucas Winter, the father of this project, created a desktop MR. When you have the magnets for the P0, you have a rotating gradient for the spatial encoding, and you have all the RF components here for in the end to get the image. And this is cost less than 5,000 euros. So this is the B0 distribution, and with this B0 distribution, you could get an image. And the idea is that to scale this magnet to the next level, to the clinical field. And we can do this by just adding more magnets. So I have an example of a magnet here. They are small, but they're quite powerful. And if you want, I can pass around. Just be sure that you don't put it together, too much together. Or if you put it too much together, don't leave your fingers between them. They're quite powerful. You can feel that. So the idea is to put more magnets to have like a bigger bore. And this was actually done here in Netherlands, in Leiden, by the group of Tom O'Reilly. He created this extremity MRI where you can scan a hand or a knee. And in the last meeting, he was kind enough to share this image. This was a knee image on this system. It took like less than 12 minutes, but it was a common turbospin echo sequence. There's a lot of, and there was no correction used. There's a lot of improvement from this side, for the post-programming side, to improve the quality of this image. There is also a project with Uganda where they want to locate the CSF in the brain, and basically in this pathology, hydrocephalus, pediatric hydrocephalus, you just need to know where is the CSF. And if you have some reliable way to localize it, you can relatively easily treat it. And they are also working together to create this low-cost MRI for children's head. And there is some movement as well to try to get the standards for this open source hardware, together with the DIN, the international efforts the German Institute for Standardization. There is a movement to try to standardize and create some guidance, some guidelines and safety guidelines to get this hardware operating and with certification. So, and many other things. I would like you to, if you want to contribute, if you are a hardware specialist, you can contact these people and maybe you can contribute with your help. But if not, you can also help maybe by spending some minutes to write in the wiki about your field of expertise. Or if you want to join to the project and upload the project in the website or be part of the meeting, just let me know. And with this, I just want to finalize with a quote of Gandhi. First they ignore you, then they laugh at you, then they collaborate with you, and then we all win. And with this, I would like to finish. Thank you.
Hi. Really good presentation.
I was struggling in the beginning.
I could see some nervousness, but
Yeah.
really good. One question, like this initiative. So, for example, if someone is not a hardware expert or something, and in the middle of the career, how can they contribute?
So if you're not an hardware, but you also be part of, I mean, I'm not a hardware specialist. I mean, I'm focused on the animal MRI and I'm doing diffusion in the kidneys. You can contribute by writing in the wiki. You can also, if you want, you can upload the project, which puts you like in contact with the project and know what is really happening. Because when I first talked with Lucas, I mean, it sounds like a cool idea, but for me it was more like a vision. But the moment that you upload the project, the moment that you contact the people from the project and you read the project, you see that it's happening, you see that it's real. And that was what triggered me to see that it's possible, maybe not in 10, but maybe in 20, 30 years. There is a movement coming. So if you want to contribute, you can join to our meetings. We'll be available in the website. You can work or write in the wiki, or if you feel can contribute as a hardware specialist, you can contact these people.
Yeah, very nice talk. I was wondering, how do the vendors look at this initiative? Do they support it, or do they think?
I mean, I don't think the market is the same, right? I mean, there a reason why there is no investment in like these areas in the world, right? Probably it's not profitable enough. So I'm not sure if if it will be like a threat or a risk for them.
Okay.
But actually, I don't know any reactions. If someone is from a company, could.
Hear me? Yeah, good. It's just a comment based on his question. There's also the whole software part for the OC. The people that are not very acquainted with the hardwares, well, there are a lot of projects in software that can
Exactly.
Need a lot of help there as well.
Yep. The OZ itself makes the project more visible. I mean, all the projects that are in the OZ are not produced by Lucas or by me. We just create the platform to just facilitate this communication, to give more visibility to the projects. Of course, Lucas is contributing with their own project for this, but yeah, you can just approach any project in the website and try to contact them if you want to contribute to any project. Or if you have an open source project and it's not there in the website, just contact me and we can think about uploading it. Because the whole idea is to give more visibility.
You might put the hackathon projects from this event on there, if you allow us to. Questions? We like your magnet.
I like it as well. But I had a lot of bruises because of them, so be careful.
I was wondering who funds these kind of projects, because it's not really a profitable project.
Sorry?
So who funds this type of project?
So I think I think the one that is, so for example, the project that from Tom O'Reilly in Leiden, I think it's publicly funded. Okay. The Lucas is publicly funded as well. The others, I don't know. I think Apple Open, they have parties funded, but they also have some small companies funding the project.
Okay, thank you.
I'm completely in love with this. It goes with all, first they fight you, then you. So, in the same breath, I'm completely in love with the talk that came before, which showed this amazing accountability and professionalism, and then the other talk about PACS, where we have to ensure that there's someone available to fix our thing at the drop of a hat, and we've got someone who we can sue if things go wrong. So how do we align those two positions? Like, I want the technology to be free and available to everyone, and yet I also want everyone to be responsible and accountable.
I just think it's not that much different than we have now. I mean, okay, my point is, like I gave in my example, I don't know how many times we are doing something that, because we don't know the system, we are doing something wrong, because we have a closed system. So, of course, that things get really messy. You find out by other ways, and then you can sue the companies. But I wonder how many times we are doing wrong things just because we don't have access to what we are doing. That's the first. The second thing is that, I mean, everything needs to be certified, right? And of course, it starts with some toy for research, but if we go for clinics, everything needs to be certified, everything needs to have regulamentations. For open source, in terms of software, it's something that is there for years. For hardware, there's nothing for the medical part of you. So it's something that is coming, that we are working in the standard and the specifications on all the guidelines and safety. And what I think is that if for a physician or for a patient who enters in the hospital, there will be no difference, I think, between going to an open source scanner or a non-open source scanner, because everything will be covered with plastics and everything. The only thing is that for the point of view who operates the machine, everything is transparent. And even for the patient, he can just look for the information, see what are the problems of my scan or what are the parameters if they are into it. But regarding who is the responsible, I don't have answer. I'm not a...
I think with the medical regulations, you are running into a problem then, because it's not about the responsibility, but in general you have to follow these rules, and that is very expensive. And that doesn't mean that that someone doesn't want to do it, but it costs a lot of time. You need a lot of people, and if you have a company that does it, it's basically that they have the whole infrastructure, and a lot of money is involved to get this done, this certification itself. I think a medical doctor wants to use open source, but maybe they can't because they are not paid by the insurance companies, because they can only use CE certified. And that's basically the problem that we are facing. But there's currently a huge move in the certification as well. So there might be a chance that there is a community or an organization which will fund exactly open source tools to be CE certified. But this is definitely a must. So there must be a community that gives the opportunity to people to work on this full time and have these regulations following. And I think that should be the aim in general.
Yeah. I mean, you can also think that kind of opens new market for insurance, right?
Tell them, yes.
Yeah.
It's a really nice idea. Like now we have like open microscopes and devices which are openly available. So in future, I think we can have MRI as well.
Yeah. Maybe to add here to this last discussion, I think from the medical people, especially in the US, they look at when things go wrong and they like to sue people. So that's also the reason why I think there is currently this company layer in between of companies that can be sued when the medical device is not working as appropriate. So I think it's definitely worthwhile exploring how far we can go with the open science initiatives to get as close as possible to clinical practice, but also think from the liability point of view. I think that's especially in the US a real issue there.
Yeah, I mean, I always think, for example, in countries like some of the countries in Africa, that I mean they don't have zero. I talk with that people in Uganda. I think liability at that point, it's not really an issue for them. They just want something to save lives. I mean, of course, if we think like in other countries, that will be much of a problem. But I mean, we need to start somewhere, right?